Welcome to a live stream on Semiotic. Semiotic is a React-based data visualization framework, highly opinionated React-based data visualization framework for developing charts and designing charts and really dealing with the information modeling aspect of making data visualization. Semiotic exposes three primary components for deploying charts. They are called frames in the parlance of the library. Those frames are designed for showing ordinal data like bar charts and pie charts, network data, which includes sort of traditional force-directed networks or directed acyclic graphs, but also hierarchical networks, which we looked at last week, and an XYFrame for dealing with XY data. And XY data just means you have data that has a range of values on the x-axis and a range of values on the y-axis. What kind of data is that? Well, it's kind of like a line chart, like this chart here, but it's also a scatter plot, so like this chart here. It's also an area plot, so just plotting generic geometric shapes, or maybe doing something a little more complicated like an area plot that uses contours to show some kind of aspect to the data and where that data is clustering. So a contour plot, which we'll get into today, is built off of the same kind of data that a scatter plot is built off of, except it's showing these sort of regions of density. Now, line charts and scatter plots and area charts are amenable to different kinds of settings. We saw that with the basic geometric shapes versus the contour plot. And in a line chart, once you have line data formatted for XYFrame and you're passing it correctly and you've told the frame how to handle your data well, then you can go into it and you can adjust the line type to show the different kinds of ways that we can represent time series data. So a traditional line chart, a difference chart that shows when certain values of the chart are higher and when certain values of the chart are lower. So this is comparing the gold line with the red line, and when the gold line is lower than the red line, then it shows the difference in gold, and when it's higher with the red line, it shows the difference in red. That's just known as a difference chart. It's one of my favorite kinds of charts. A bump line chart that charts changes in rank. A stacked area chart that shows aggregate changes in value, so you can see sort of peak aggregate regions. And a bump area chart which combines those latter two to aggregate the values, but also to change the position of the ribbons or bands when those values change in rank. You can adjust the curves, so the interpolation method, so that you can use different curving interpolations based on the kind of data that you've got. And we'll, again, get into all of these ways of changing these settings when we start to deal with the data. So speaking of which, let's go to CodePen. Here's my CodePen profile. I've already created a couple of little pens that don't do anything. You can see some older pens. But we're going to open up Semiotic Scatterplot Basics, and that's what we're going to start with. And so let me copy the link specific to this CodePen, and I'll drop it into chat. As I say every time, if you have something that you want me to dive into, my plan today is to look at XYFrame and really look at how to use the functionality in XYFrame so that you can make not just sort of standard scatter plots and line charts, but you can make rather complicated charts and use the annotation functionality and all of that to make some really cool charts. That said, if there's something someone out in the audience wants me to focus in on, I'd be happy to deal with that. If you have specific questions or you want me to go back and talk about some other aspect of the data or of the code, I'm happy to jump into that. Likewise, Semiotic is not a low-level library like D3. However, it does allow for moments in the creation of charts to step in and do D3 things with data and shapes and graphics. And so if you want me to explain or focus in on the D3 aspects, well, it just so happens that I'm kind of an expert in D3. In fact, here's my book. I'll get the Amazon link for it instead of the Manning link. Kind of wrote a book on it. So if you want, you can go and ask me questions about D3, and I'll be happy to jump in on the D3 details when those pop up. So with that in mind, let's get started. I got this English Premier League data, which I believe is soccer. I don't really know, but I found it on Kaggle, which has all of these data sets. And when I looked at it, it looked like it was very much the kind of data that would be amenable to XY plotting. Let's go take a look at this Premier League data. It consists of an array of objects. Those objects have these different years. So we're looking at from when they started playing soccer back in the 1800s all the way to now. Must be a pause. Did they pause during the wars? Is that why? I don't know. It looks like 1919 to 1920. Yeah, it looks like they at least took a break during the Anschluss and other, I don't know, Franco-Prussian wars. Who knows how they play soccer? My point is, we've got this nice set of data that goes back throughout time. In each of these, there are 3 tables of data, which consist of what I believe are just the leagues. Right? I'm pretty sure Premier League is the top league, and then these other 2 are probably the lower leagues that teams get bumped into and out of. So this is really great because what it shows me is once we dive all the way into this relatively convoluted data set, what we end up seeing is a bunch of numbers, which is what we want for XY data. We don't want too many categories. We want a lot of numbers for a variety of different teams over time. And one of the steps here that I'm going to get into that you might find interesting, you might not find interesting, is taking this convoluted data and processing it so that we can actually get out of it some XY coordinates. So looking at these tables, I think I'm only going to stick with Premier League because that's the only one I've ever heard of. Which seems to be the first table in each of these. And it's interesting, whoever made this data set even includes the corporate sponsorship, which I suppose is something to do. So let's take a look. We'll assume that the first table, and then we can come back if it's not, we'll assume that the first table in each of these is the Premier League data that we want to work with. So how do we process that? Well, we take that Premier data JSON file. We'll make some XY points, right? XY points is going to be an array. That's not what I want. I want this. We're going to walk through the objects in Premier data. So Premier data for each, and then trying to think of a nice, let's see, what are these, teams? Too many things. These aren't teams, I guess they're years, right? And then year, wow, I've got like a million different things that Google thinks are Chrome. So every time I try to tab back and forth, it just jumps out at me. So each year has a tables, year.tables of 0, right? Year.tables of 0 dot table rows for each. And that should give me a row, right? We'll see. We'll see what it does. That should give me a row. I should be able to say XY points dot push the row. That's one way to do it. And then let's console log XY points. Console log XY points. I have a feeling because CodePen has not responded with this over here that I've missed something. So let's see what the error is. Cannot property table rows of undefined. Well, what are you? If you're not table rows, let's say console.log year. Cannot read property table rows. Oh, look at that. Isn't that interesting? Some years have no tables. What a wacky data set. We'll see what happens with this. This might be, I'm sure it'll be useful enough, but it might not be as much fun as I thought it was, because I didn't go back to 1977 to see if it had exactly the same. So, simple enough. If year.tables of 0. I'm hoping that they're all arrays. That should work just fine. If year.tables of 0, then push into xy points. And then let's see what it says now. Console.log xy points. I think I'm already doing that, aren't I? Isn't live streaming great where you can watch somebody who has no mind of their own? So this hopefully will be each year, each team with whatever those numbers are. And that's what it looks like, which is what I wanted. Tottenham Hotspur. Is that a real place? I doubt it. Okay, so I've got a nice array of data to start with. However, you'll notice that this data array doesn't include the year, right? So there'd be no way for me to tell Burnley apart, that Burnley came from the whatever, 1974 data or the 2017 data. So let's make sure before I pass it into the array that I take this year value and I assign it, right? Use object assign. I use object assign all the time now. It's like all I ever do. An object assign just takes an object and another object, and it maps the properties of the second object over the first object, right? Or as many objects, I believe as many objects as I want over the first object. So year.year, and that should work. Let's go see. Why is it complaining? Object assign an object over a row. I need another parentheses. Okay, here we go again. And now we see it, and presumably when I look at this, perfect. So now I've got a year in here, which is great. I'm going to do a few things just to make this straightforward. First, I'm going to split the year off and just turn it into an integer, because I don't want to deal with this sort of half-year thing. I realize that maybe that's not always the case. Maybe there's some years that aren't halves or whatever. But I'm going to take the first value, because it looks like in some cases the second value isn't always a 4-digit year. And I'm going to use that as my year. So I'm going to say year.year.split on the thingamajigger, and then I'm going to parse into that. Or I'll just, yeah, I'm going to parse into it, because that'll look cleaner for the example, right? Parse int. And I have to get the first value in that, obviously, because after I split it, it's an array. And let's go. I keep going back to my Twitter. That's not what I want. You keep seeing my Twitter, my notifications on my Twitter. Okay, so now this is exactly what I want, right? I've got a year, and it's an integer value now. And then I've got all of this stuff. So I'm going to assume position was the ranking. That's my guess there. Points seems like, so if position 10, points, the same amount of points. Once I see points that are higher, yeah, great. So that's my guess, is position was the ranking at the end of the year. Points, pots, losses, draws, wins. I don't know what if anybody is watching this and knows anything about Premier League and can tell me what any of these stand for. Position, points, wins, losses, and draws are what I'm going to work with. If it turns out there are other things, that these other strange letters stand for. And you know how the British are. They use weird words for things. So this could be lifts and like hot toddies or whatever else it is that's going on in that strange little island. Let me know. Otherwise, like I said, there's enough here with wins, losses, draws, points, and position for me to do fun things with. So, Premier League data. Got this nice little array of points. I'm going to go walk through that array of points. Actually, let's keep that up there as a console log. And why am I going to do that? I'm going to go and cast all of those values as integers, just so they'll be easier to work with, right? So for each of these, I'm going to say point.w equals plus point.w, and so on for the things that I plan to work with, which will be wins, losses, draws, position. Who uses capital letters for their properties anyway? Who capitalizes their properties? And points. And I know that technically this is supposed to be data visualization and not data processing. It's supposed to just be a data processing live stream. But as everyone who deals with data visualization knows, there's a lot of data processing that you do. So I don't mind walking through this and you seeing this sort of process to how I process things. But now we look at this, and sure enough, we got integer values in those things that I want to map. So now we can finally get to some data visualization. Now, CodePen uses a particular way of importing functions, and then so you can import sort of your JavaScript libraries over here. Click on settings, you go to JavaScript, and you see all of these libraries that I'm importing, including this Premier League data. So 1.4.3 of Semiotic is being imported in from unpackage, and that's how I get access to the components that are in there. So I'm importing what you would normally say like import XYFrame from Semiotic, instead is const XYFrame equals Semiotic, using the sort of object destructuring of the variable names. Or object assignment. I don't know what the term for that actually is. So anyway, so down here where I say make a scatter plot, I should follow my own advice and put in a little scatter plot. So that's an XYFrame component. That XYFrame component has some attributes. It's going to take, it takes points, lines, or areas. So you pass your data to either points, lines, or areas. In this case, since we're doing a scatter plot, we're going to do points. I'm going to say points equals those XY points. That's what I call them, right? I've already forgotten everything. And here I am. Okay. Now, so it's got this point data, but what it doesn't have is it doesn't have any rules for how to display that point data on screen. So I need to tell it, well, what's my x value, x accessor, and my x value will be wins, right? And then my y accessor, and you can see that it's already starting to show things on there. My y accessor will be, say, draws. So is there any correlation between wins and draws? And you can see maybe, hard to tell. We can't read it because we have no axes, so we should probably throw some axes in here. And axes, unsurprisingly enough, is a property called axes. It takes an array of objects that describe the axes that you want it to display. So let's say we want one on the left, and then we want another one on the right. On the bottom. Why did I say right? And now we have axes, and you can see I scroll down a little bit. I see it here, kind of a small screen space. So I'm going to change the size of my XYFrame, which is by default 500 by 500. I'll make it 400 by 400. It'll be a rather small example, but now you can see it. So now we have some sense of wins and losses, I believe. So we can label these. Label of the left, because the left is the x-successor, then that's wins, right? And you can see it's showing, but it's showing a little off screen there, so we'll adjust the margin in a second. No, x-successor, y-successor, draws. There we go, that's better. And then label wins. And like I said, we can adjust the margin, which is again another object that you pass, where we can tell it, so actually margin could be a number. We could say, give me 20 pixels all around the chart. And so we could say, give me 50 pixels. And then it might show these things a bit more. But really, you can also send it an object, and that object can have more specific commands. So the left side, since we need a little more space on the left side, can be 70, and the bottom can be 50, and the top will give it a little bit, and the right will give it a little bit, just so little scatter plot points aren't cropped off. And there you have it. You have a little scatter plot of draws by wins of the English Premier League since 1888. Which is interesting to me. It's interesting, not understanding soccer at all, to see these really high draws, numbers of draws, compared to wins. I expected it to be that the more wins you received, the fewer draws you would have. That said, what we're looking at here, this is actually super amenable to contouring, because unfortunately, under the hood, you have no idea how many things are being represented by this individual point here at like 4 wins, right? How many teams must have had 4 wins and 6 draws? So let's go do hover annotation and go find out. Hover annotation equals true. And that should turn on little tooltips. We don't have any CSS in place to handle those tooltips. If you wanted to, you could add some CSS that said tooltip content, and you could say give it a border, 1px solid black, and you could give it a background. And you'll notice that a lot of my examples have this already set up, but here's how you do it. And you could give it, I don't know, some padding, 20px, and then when you go and hover around it, you can see where it's at. And you could move this tooltip around so that it was centered above it with a little triangle underneath it. And the CSS for that is included with most of the examples that you run into with Semiotic. Now what's interesting here is it's coming back with a generic tooltip that's giving you the X value and the Y value for where it was plotted. So we can tell that it's 7, 7, right? We're at 7 draws and 7 wins. And now we're at 7 wins and 8 draws. That's not very interesting. So we can adjust our tooltip content by passing a function, and that function returns some JSX HTML, JSX, whatever that's called. And actually here, let's turn this, make this a little more explicit. Return an empty div, and before I return an empty div, let's console log what's being passed through to D. So clear out a little console because this has gotten rather bulky, and let's go take a look. And here's what's interesting. So D, what's being passed to your tooltip content, is the properties of the point you're hovering over, a type, because it's an annotation, and there are built-in rules for handling this annotation type, which we can get into. And then a property that's called coincident points. And coincident points says how many other things are also on this point. So it's giving you the top point in the list, right? And in a lot of scatterplots, that's going to be the only point there. But in a scatterplot like this, it's also giving you coincident points, which is an array of all of the points at that location, which includes whatever data you're seeing at the top level here. So if we go and look at this, Actually, it seems like there's not so many coincident points, which is sort of surprising to me. I would have expected there to be more. And not looking at the data, it's hard to tell. Here we go. So at 4 draws and 0 wins, 1979, 1963, and 1891, the Bolton Wanderers, the Ipswich Town, and Stoke City all had that same value. So you could, if you wanted to, factor that into your tooltip, right? You could say const displayed values equals d dot coincident points dot map. And we could take those coincident points, which is an array, right? And we could map them, and we could return for each of those points a paragraph element says something like this, something like, let's go see, what are these things called? d.team colon wins. Oh, well, we know the wins and losses, so we can put that at the top. So we'll deal with that in a second. d.team in, what is it, d.year, right? d.year. You can tell that I wrote year because it's in lowercase. Okay. And then we could drop that in there. Displayed values. And as I was saying, we probably want to actually tell you what the wins and losses were. So we put a little paragraph here that says wins. And that would be coming from any of these. So we can just use d.w. And then losses. Wow, CodePen is not dealing well with, not losses, draws. Sorry about the way the code looks. It looks like it just is not happy with the line breaks for doing all of this JSX stuff. So we can do this in a separate function up top, and I'll start to do that moving forward so that you can read it better. Because this is absurd. This should be like all the way over here or something. Come on, CodePen. I do like CodePen more than the using Semiotic examples repo, because conceivably you could be jumping on right now and forking this and fiddling with it on your own. So let's go take a look now. Oh, I have to give my div that class name, right? Because I wrote some CSS rules, and now I'm not even using them because I no longer have a class name for what I'm returning. So keep that in mind when you're writing your tooltip content. That you're just returning a div that's going to be centered on it's going to be positioned just above the point that you're hovering. So whatever you need to do for CSS, you need to do that. And sure enough, oh, this looks like there's some issues. Oh, there are some issues, right? Because I'm going to, you can see, this is that whole D3 thing of using meaningless variable names. D is that top level point I'm returning, but my data is coming from coincident points to which I'm assigning P. I was going to say this data set seems like it's got some problems, but no, it's me. Okay, so now we can look at this. Now we can see just what a mess British soccer is. Is it British soccer or is it English soccer? Who knows? I don't think anyone knows. So 2 wins, 1 draw. Queen's Park Rangers in 2014, Derby County in 1990, Middlesbrough in 1980, Notts County in 1891, West Bromwich Albion in 1890, and Derby County again. Boy, Derby County had its almost, it just missed the centennial of its 2-win, 1-draw season by 2 years. That's sad. That's funny though, right? Because they could have that and they could say, we haven't had a 2-win, 1-draw season since Queen Victoria or something. I don't know who the Queen was in 1888. And neither do you. No one does. I don't think anyone knows. And it's good to see some Republicans represented in the data set. Anyway, this is fundamentally how it works. And if we wanted to, we could go and identify maybe a team in here, and we could color a particular team, let's say Manchester United, the only team that I'm aware of. Not that I would be able to recognize their uniform or anything, but I've heard that name. And say Pointstyle. Pointstyle will take an object, and it'll take a React style object. So we could say fill equals gold, right? And then all of these little points would be gold filled instead, or we could say dark red. Oops, spelled correctly would probably work better. You could see some points. We could go into CSS and maybe adjust the axis elements to. This is one of those things I'm always talking about where I try to remember. So that's the text, axis text, fill. There we go. And then I try to remember what my CSS names are or my functions are and all of that. It's always very interesting to me. So let me see if we do the paths. There we go. Excellent. That makes me feel good. We have these baselines that are a different. They're a different CSS class, which I believe is baseline, and stroke equals like gray 2. We could get rid of them entirely. I don't really like baselines very much, but some people do. I don't know anybody who does. My kid. Let's see. Maybe it's not called baseline. I'll have to go look it up. In D3 they were called domain, but I didn't really think domain was a good CSS name, so I did not think that I used domain. Anyway, I'll go take a look and see why that's not at some point, but I don't want to get too caught up in that. What I wanted to do was, so we've got this great little tooltip that tells us all the teams that did so poorly whenever they did them. The most wins was 28 wins and 6 draws by Everton in 1984. And then Tottenham. Hey, there's some Manchester United. I knew I'd see something. They'd have to be, oh, I think I've heard of Arsenal too. Anyway, that's not what you tuned in for, right? I mean, not entirely. So, Pointstyle, all of the style functions within XYFrame, can take an object and it'll assign that object all of the elements being displayed. Or it'll take a function, and then it'll evaluate that function for each item, right? And it'll return an object that is a style function. But in this case, now that we're taking a function, we could say d.team equals Manchester Arsenal. Arsenal's easier to spell. Arsenal, question mark, then blue. Otherwise, dark red. And you can see now little blue points popping up here. Now, if you wanted to actually display different kinds of marks, that's a slightly different interface, and that's custom point mark, which again takes a function or takes a JSX object, and you should be able to return just sort of bare SVG. So you could say like circle r equals 5. And we could say with that function the same thing, right? Where we say team equals Arsenal. Oops. And make it a 5, and otherwise make it a 3. So it's easier to spot. Hey, wait a minute. D.team equals Arsenal. What's going on here? What's wrong with my logic? Function t.team equals. As I've always said, I don't want to get too caught up in this stuff. but I do want to see what's going on. That should have simply worked. So return u, and then console log d, and see why d doesn't seem to have access to d.team. Oh, I do know why. And that's because this function, there's a little bit of mismatch throughout Semiotic. This function, it expects you to destructure. What's going on here? Expects you to destructure. And that's around a lot, and in later versions of Semiotic, when I finally want to make this sort of break and change, it's going to be the case everywhere, because I just think that object destructuring for variable names is just a much better approach than sort of old-fashioned JavaScript. So we have to destruct, if you logged this, you would have seen this, right? You would have seen that this is an object with all sorts of different properties, one of them being D. That gives me access to the items, and now we can see in some of these places where there's multiple items being plotted in the same place, you can see that some of them are arsenals, right? And in some cases, arsenals on top, and in some cases, arsenals on the bottom, so it seems like, so it's not being drawn in any particular order. If we wanted to, we could sit here and say, change the opacity, just so you're not visually confusing people, so that they can see that that arsenal is the only spot there. And in fact, by changing the opacity, you get a certain sort of aggregate plotting that starts to get us toward that contour plot. Now, I thought I was going to get into a lot of different things, like line charts and all of that, but I think we're going to just be in XYFrame and just be dealing with how to do scatterplot kind of stuff, because frankly, this has already taken a while. And it makes me, this data set makes me want to get into doing areas, because I think it's really just amenable to contour plots. XY points, let's go see. Actually, let me see. I believe all I have to do is say area type equals contour. Let's see what that does. Maybe not. So here's where I go, and I haven't made a contour plot live before, so I'm going to look at my code. So let's go look into the example, the XYFrame example. And it's a mess of code on this end. It gets processed to be relatively pretty on the other side. But I'm going to go and look at area type hash, areas, area type data, area data hash. Isn't that an amazing way of doing things? Contour area data. And, oh, here we go. Okay, so I was mistaken in what I thought contours took. So contours isn't capable of just taking an array of points. Contours, so areas, is another set of data. So there's points, areas, and lines. That's what XYFrame deals with. And so areas will take an array of objects, and those objects have a property called coordinates that you can use to draw contours. And that's literally what's happened over here, is we've already drawn these contours. It doesn't need the ID. The ID is being used under the hood in some places in the example, so we can get rid of the ID just so it's not confusing. And maybe my stream is dying, or maybe not. Seems to be showing, okay, who knows. If there are problems, for the many thousands of you out there watching at home, let me know, and I'll make some kind of joke about them. We've got a contour plot here. Now, the challenge with this contour plot is that you can't see anything. And, it looks like a blob. It looks like a black blob. I'm going to take the custom point mark. I'm going to reduce these point sizes, make them very, very small, so that they're not graphically jumping out at me. Just like we have point style, we can you do an area style. Areas, depending on what kind of areas you're displaying, with contours, typically you just want to apply it to the entire contour set. And so we'll just send it a bare object. We'll give that object a fill of steel blue, just to be like a call out to the olden days of D3. And a stroke of dark blue, just because it's easy to remember. And there's our contours, sure enough. It's just that they weren't showing because we didn't have any stroke to them. And so it's drawn these contours using under the hood D3 contour to show you the density of the points in this scatter plot, and it's doing a very good job of it. You can change the opacity, maybe just the fill opacity, so that we can see again that aggregate, because it'll build up. These contours will build up on each other. It's a little too little. Again. And so they're building up because the contours aren't sort of individual rings. Each shape takes up the entire area. It's not cut out. I hope that makes sense. But contour plots are great for scatterplot style data. If you want to, you can just have area type equal to contour, or you could send area type an object of type contour, and then you could change all of the different settings under the hood. Let's go take a look at what those settings are in D3 contour and just pass them through. So D3 contour. There's two kinds of contour functions in D3 contour. This is using the simpler one. You can see all the cool stuff that Mike did as an example. So this is a density contour, the density estimation based on points, which means you can pass thresholds. So it has the individual thresholds if you want. What I wanted wasn't thresholds, it was bandwidth. And you can adjust the cell size and things like that too if you want to, but I find that bandwidth, so we can change bandwidth, which is dynamically calculated, and you can see just immediately what adjusting that does, right? We can make it larger, which is going to make it much more sort of smoothed out. We could make it smaller, which will make it much more affected by the row-like nature of the data. But it'll also show more patterns to sort of where the data is really aggregating. Reading documentation with me, Elijah. Threshold is specified, sets the threshold generated a specified function of or array and returns the contour generator. 20 nicely rounded density thresholds. If a count is specified instead of an array of thresholds, then approximate count uniform. There we go. That's what I wanted. That's what I thought. I thought that it took not just an array, but also a number. And that is thresholds with an S, and that's why it wasn't listening to me when I said threshold before. Okay, so thresholds, let's just adjust this and play with this. That's supposed to take 20 to begin with. Ooh, look at how terrible that looks. Once you increase the number of thresholds, then you want to increase the number of bandwidth. The bandwidth size. So otherwise it starts to get kind of terrible looking. Ooh. It just seems like no matter what happens, it just doesn't get better. And that's one of those fun things with data visualization, right? We make the bandwidth too high, and it all becomes very sort of blobby. We make the bandwidth too low, and it looks crazy. So let's see if cell size. I don't think cell size is going to change much of anything, frankly. cell size. Yeah. Anywho, so there are some. I'm not even sure that I'm passing cell size. You can adjust the settings, and it's being passed directly through, and it'll let you create a contour plot that's similar to the contour plots that exist within D3, any of the sort of density contour plots that are examples in D3. And if it doesn't, you should let me know, because if it's not, then that's a bug. But anyway, that's there. That works. And like I said, I don't want to get into lines because that's going to be a little bit more involved. You'll notice again that points is an array of points. Areas is an array of area objects that you're going to want to... Oh, in fact, here's something fun we could do. We could make this... So this is an array of objects. You can have multiple contours, right? Multiple calculated contours. So we could sit here and say, give this one a color of steel blue, and bear with me, it'll make sense as things start to go. And then we'll say xypoints.filter, and we'll filter out only Arsenal, right? And that gives us a contour plot that's just Arsenal. And now, because we're not getting so oversaturated in those dense regions, that it's doing a sort of distant contour, which is more what I was looking for. I'm going to see if I can reduce the thresholds a bit and get a slightly better looking shape. Increase the bandwidth, I don't know, more thresholds, fewer thresholds, higher bandwidth. Seems like there's the stream is not doing the best job of keeping up with me. Maybe it just can't handle these amazing data visualizations. Anywho, so we've got one object showing Arsenal's distribution on this plot, and then we can have another object. Let's go find a really sad team. Let's say, like, what's a really terrible team? Not knowing anything about soccer and just looking at these sort of distributions, say, looks like Everton's a really terrible team. So change this one to dark red, and then say Everton, and then we'll change the, now they're on top of each other, right? So we can change the area style to a function. And what we can return in that function is that d.color, right? Hey, that was supposed to work. Function, object, d.color. I definitely have a color in my object coordinates color. So here we go again. You should be used to this by now. Return that object, and console log D. Let's go find out what's going on with D again. Wow, there's been a lot of console statements since last we looked. It's in something called parent area. And that's because what's coming back from D, I remember now, I haven't worked with contours a lot in the last month or so. What's coming back from D is each individual polygon. So you could adjust the whatever you're displaying based on the polygon's attributes, such as the values that are being aggregated within this band. Or you could reach up into the parent area that generated this polygon for styling information or whatever information. D.parent area.color. And there we go. We have two contour plots, one of a very good team and one of a very horrible team, right? Make them a little bit lighter, And I think far fewer thresholds when you're doing some kind of analysis like this. And you might even want to say, make that into the stroke, change the fill to none. Opacity to 0.75. Stroke width, we'll make it a little bit larger so it's a little more readable, especially on this tiny little screen. And go back, change the thresholds again. You can see like changing thresholds, like contours is just all about putting way too many and way too few thresholds over and over again and adjusting the bandwidth and so on and so forth until you finally go crazy. So I know you don't want to watch me go crazy. I'm sure some of you want to watch me go crazy, but the nicer ones don't. So I'll stop. I'll stop there. With that in mind, for those of you at home who are trying to use this in production, you might notice that it bleeds over, and it's annoying when it bleeds over. And you can actually set, the XYFrame has a map property that if you set to true will clip anything that's bleeding too far outside of the chart. So that way you can still read your axes. At this point, now that I've turned these into lines, which I can fiddle with some more because, of course, I'm just going to continue to fiddle with this. That's what data visualization is about. I'm going to make them dashed lines. Dash array equals A2. Let's take a look and see what that looks like. Yeah, that's possibly better. Yeah, that makes me happy. And then I can make the points larger using that custom point mark again, right? In this case, I can say like, where is Arsenal? I can make Arsenal into steel blue. And otherwise, don't use nested ternary statements like me, kids. Otherwise, Everton, right? Otherwise, gray. See if that works. Yeah, that's kind of what I want. And then I could make these d.team equals Everton, or d.team equals Everton. I know I said Everton the first time, but you knew I meant Arsenal because that's what it says on there. And make those a little bit larger, make the other ones smaller, but larger than they were. And then make the opacity a bit higher. So you get kind of a sense. And I think you can see where I'm going with all of this. I'm a little surprised. It doesn't look like, did I misspell Everton? How did I spell it right up here? d.team equals Arsenal, steel blue, Evertone with an E. How awesome is that? And I did it twice. There we go. Perfect. And make it a bit larger because I'm going to take a screenshot of it, use it as my whatever. Oh, that's nice. I like that a lot more, don't you? Stretched out like that. And make this, yeah, slightly larger so it'll make a nice screenshot so that I can show it to human beings out in the world. So you could have made this. If you tuned into YouTube, you could have seen something like this. And I'm going to stop there because I think that's frankly quite far enough. I That's a cool little plot that you could have made that's using contours, that's using scatterplot principles. It's got some hover interactivity on it that, of course, could be made better if you understood the data set, you had a story to tell, and so on. But in general, I'm pretty happy with what it shows off with XYFrame's functionality. As usual, if you have questions for me, please feel free to contact me either on Twitter or in the chat during one of these live streams, or file a feature or bug report on the Semiotic GitHub, and so on. I'd be happy to dive into any particular subjects you want me to look at using Semiotic especially, and data visualization more generally. And until then, have a great time. Thanks for joining me, and I hope you found this useful.